analysis of star data. Here I am going to use it in R, and you will find the link for the video, for the commands used in this video in this introduction to econometrics with R. I shall provide this link in my video. Okay, library tidyverse for general purpose, instead of pressing library dplyr and library tidyr, library applied econometrics with R. Star data is built in that. Star data is available in this applied econometric with R. So data static, data star data, if you want to see it, glimpse. Now you see, glimpse is to get overall view of the data. What is it? So you have 11,598 observations, 47 variables. You see, this is a factor variable, integer variable, and you can have the overview of all these variables, and you can see experience in KG, experience in grade 1, and all that. If you want to see more on it, go to WebStar data, go to WebStar, and you can get all these details. Now what we are going to do, we are going to basically regress on test score, on student teacher achievement ratio if a student is in kindergarten. So these two are added, and we regress linear model if kindergarten. You have 3 classes: KG, regular class with aid, regular class with aid, and kindergarten are dummies are included, whereas regular class is considered as reference category. So for kindergarten, for grade 1, for grade 2, for grade 3, and then you can obtain robust standard errors, coefficient test, FMK, various covariance, heteroscedastic corrected standard errors. And what do we see? That on average KG children get on average student studying in KG with small class size have test score points 13.89 more than a person than those who are studying in regular class. For more details on this interpretation, please watch video number 38, analysis of star data, where I have discussed their interpretation. Here I am interested how to use R to calculate these results. Similarly, for model grade 1, for grade 2, for grade 3. Now we can have robust standard errors for all these one, FMK, FM1, FM2, FM3, and we'll demonstrate these results in form of a column. There are 2 libraries which are very useful. One is Herc's table, another one is Stargazer. So it's up to you which you want to use. So here you are going to give title of your table as project star differences, header false, library a type text if you are using latex. If you have latex or some other, you can use HTML. I am using here text, model dot numbers, okay, digits up to 3 decimals, dependent variable, and all that. So you can take look into it. So you have now this table. You see, this is your title, these are your dependent variables, KG 1, 2, 3, and similar results which we have the same results which we have already discussed. So now what we are going to do, basically now we are going to include W variables, some other exogenous variables which must be there, so that there is no omitted variable bias like gender, like pre-lunch, like race, and all that. And for that we need to extract that data, and to extract that data we are using this pipe operator from library tidyverse. So star, and then we get these variables, and then we apply some mutate to calculate new variables, ethnicity and gender. So just control enter, you will get all these variables selected, constructed, and if you are not sure, just go to glimpse star k, you will get, now you have 11 variables only with 11,098 observations. If you want to see, and now you have factor, doubled means ratio scale variable. So estimate the model. Now we are going to regress math reading score of KG children on student teacher achievement ratio, experience of teachers in KG, and similarly grade 2, grade 3, and similarly you can go for again for various covariance robust standard errors, and you can all that. And again you can get these results, collect these results in form of a table, and again you have a table, and you can see what difference it does it make. Now you have these results are very much similar to the previous one. Okay, now we want to standardize these results. You see, California, Massachusetts data from chapter 4 to chapter 9 of Stock and Watson, which I have been discussing in many of my videos, some were in Urdu, Hindi. Now here you see, we want to compare these experiment results with those observational data. To make comparison, it's important that we must have these coefficients measured in standard units. To measure those in standard units, what we are going to do, we are basically first of all going to calculate standard deviation for the reading score and math score for KG, for grade 1, for grade 2, for grade 3. For each we have calculated the standard deviation, and now we are going to basically for KG as dot numeric, so the coefficient which we have achieved divided by standard deviation of 1. So you see SSD1 means KG standard deviation, SSD2 means grade 1 standard deviation, SSD3 means grade 3. So you can have these standard unit coefficients in standard units, and now you have small, so KG 1, 2, 3, small classes to standard deviation. Adjust the standard errors. Again you have a regular class, and adjust the standard errors. So you have adjusted the standard errors, and now you are going to express in form of a table. So you look here that 0.19 in standard units, that if you move 0.03 standard unit above that, your test your student test score will improve by 0.22, by 0.03 units above 0.9. So you can compare these results with California and Massachusetts, as I have discussed these results in video number 38. So for more interpretation and for comparison, please read chapter 13 Stock and Watson, and watch my video number 38 if you like. Thank you for watching. Take care.